The previous videos on my channel have been focused around image processing using star tools, for which I've been very impressed with, and based on the amount of hours I've put into it and the number of videos I've made, I feel quite comfortable around it. However, it's time to step things up and take a look at PixInsight. Before using PixInsight, I read a lot about it, and the general feeling is that it is very detailed, very powerful, yet perhaps overly complicated. I've put quite a few hours into reading, practicing, and following tutorials to get to the state that this video will show. However, to help break things down, I've focused on making a workflow that can hopefully be used in the future for further broadband objects such as the Andromeda Galaxy in this video. The workflow that I will go through is looking at the basics that we want to do with any image when processing, such as background and color calibration, noise reduction, detail improvements, along with a hint of star reduction. That is the aim of this video. I hope it's informative and shows the beginnings of my PixInsight journey as I begin to understand and use this powerful astrophotography processing tool. While watching this video, please remember I am still learning, and any constructive comments or feedback is appreciated, so please feel free to leave one. Thank you. So I've loaded the stacked image into PixInsight, and the first thing we're going to do is stretch or auto stretch the image. And this is a temporary stretch by clicking what we're going to call the nuke button in the top right hand corner here. And this shows us what we've got to start off with. So the first thing I'm going to do is rotate the image for personal preference through image, geometry, and in this instance, rotate 180 degrees. And then the next thing we're going to do is crop the image to get rid of any artifacts or stacking artifacts on the edge of the image. So this is process, all processes, and dynamic crop. And then we just simply highlight or select the area we wish to keep. And anything outside this area is cropped away when we click on the green execute tick button. And we can just refill or zoom to fit. And there's the image that we're going to start working with. I'm going to close the dynamic crop process. So we're going to start off with the dynamic background extraction process. And what this does is it allows us to remove any light pollution or gradients within the image, and it gives more of an equal background color. So technically, we're going to be removing the unwanted signals which cause these variations in brightness. Now, using the dynamic background extraction process, or DBE process, we're going to be sampling the background in several different places, and PixInsight then creates a model or samples these background areas and creates a model which then is subtracted from our original image. The result of the subtraction is a new image. However, these unwanted gradients or unwanted signals having been removed should provide us with a more equally balanced new image and with a better background. So to create the sample points, first off, we click on the image to say that this is the image that we want to work with. I'm going to set the tolerance to 1.5, and the tolerance is basically a higher tolerance identifies brighter pixels more in the model, but at the risk of picking up pixels that are not really the background. But if we have too low a tolerance, then obviously we lead to a poorly sampled model. Okay, so other options that I'm going to change here, I'm going to change or make sure the default sample radius is 17. The radius is how many pixels each sample point is. We're then going to increase or keep the samples per row to 10, and we're just going to generate these sample points. And I'm just going to change the color of these sample points to yellow, just so you can see where it's placed them. Okay. So each of these yellow squares is a sample point that's been created, and we move through these sample points using the arrows here. And what we're looking for is, if it's black, that means the sample point is covering a star, which the star is not the background. So we just move the sample point by clicking and dragging to an area where it's white, or we cannot see a black blob, which is the star. And we just keep moving through the sample points, checking all of these off. Again, there's a small black area here, which is a small star. And I'm just going to move this sample area subtly to the side a bit. So we don't want to drastically move each of the sample points, because these have been placed in rows equally across the image. And by leaving them in the rows in the same areas, this is how we can get our best sample across the entire image. What I'm going to do is, with the galaxy, I'm going to delete out any sample points that are on top of the galaxy, because obviously we don't want to be sampling the galaxy, as the galaxy is not the background. So just having a look around there. Just going to move this one out a little bit more. Okay, so as much as we can out away from the galaxy, either by moving them or deleting them. And then I'm going to just start going through the sample points again. So all I'm doing here is clicking on the arrow and looking in this square area. And if anything black appears, I'm going to move the point slightly. Okay. If we had had a larger radius at this point, then the sample box would have been taken into consideration a larger area. Okay, looking good. A few more to change. Okay, so the final option we want to choose is subtraction, because the model that PixInsight creates, we want to subtract away from our original image to create as a result, again, of a balanced new image with a balanced background. So once we're happy with this, we'll just click on the green tick and it executes it. And what it's created is two new image files for us, or two new images. This one that's headed background, if we click on the auto stretch button, we can see the model that it's going to apply, or it has applied. So this is like the gradient, as we can see. And that gradient was removed from our original image to give us this new one with DBE as a postfix. And if I stretch that, we can now see our new image with more of a balanced background. So I'm just going to iconize the original image, and moving forward, this DBE will be the version that we work with. And we'll finish with a dynamic background extraction, so we can just close this. This warning here is that it's still linked to our original image. Do we want to cancel this link or session? And we're just going to click yes, because we're finished with the original file, and we're going to be working through with this new one here. So the next step we're going to be doing is color calibration. And like a lot of things in PixInsight, there are multiple ways to do this. But one of the cool features within color calibration or PixInsight is photometric color calibration. Now it does this by taking the parameters of the image, whether it be like the right ascension, the declination, the observation date, etc., etc., and it then looks all of this up against a database, finds the object, and through plate solving, it matches it to the database, and it applies the background and a white color balance to the image itself. So I said this is one of several ways of doing color calibration, but this way I think it's obviously accurate if it can plate solve against your image, and knowing what colors it should be or what it can calibrate against. So there's a few things, there's quite a few options here, but all we need to do is we are broadband image. We are a spiral galaxy, the M31 for this object. Otherwise, you can choose different types of white reference, I guess, selections. We are going to search for the coordinates, which fills in the right ascension declination for us. So in here, I'm just going to type M31. I've already got this in here. Click on search, get, and it's populated the parameters for us. So this is just basically telling PixInsight the positioning of the image, such as in plate solving, and then it can use that information to look up within the database. The observation date when I took this image was, I believe, the 11th of November 2020. Fill that in. The focal length of my scope and camera is 480, and the pixel size of the camera of the sensor is 3.72. So manually look them up, and I've manually typed them in. You can try acquire from image, and if those details were saved as metadata against the image, it'll automatically pull them through. But in this case, I've had to manually set them. Okay, so we leave everything else as default, and then we just click on apply, and this will take 10-15 seconds, where it is looking up against the database for all of the details and parameters that we've set for our image. Once it's located it will then apply the color calibration settings automatically to the image itself. If it fails during this calibration, double check that you've got your observation date, the focal length, the pixel size correct, because those being incorrect, it can't plate solve, and therefore it's unable to find a valid position or image for it to base its color calibration on. So to check what this looks like, we need to remove the stretch, the automatic stretch from before, reapply the stretch, and we can see here what the color calibration has done for us. So at this stage here, generally we'll have like a green tint to the image, and using this tool here called SCNR. Now, these are processes that I've already used before. I can either double click on them to open them again, or we can just go through the menus, process all processes, SCNR, and it'll open it up for us as well. And here what we're going to do is we're going to subtract the chromatic noise or tint from the image. So we're going to choose green. So this is showing a bit of a green tint, and click on the square to apply it, and that'll take the green tint off, and we're looking a bit more like a black background or more balanced background now. So continuing down the processes, I'm going to set the RGB working space. Now why this is important is every time we create a mask, we are basing it off the luminance of the image, but rather than, as you can see here, the RGB settings having 3 different ratios, I want to make sure that all red, green and blue RGB have equal weightings in any of the luminance masks that I've created. So push all those up to 1, click on the circle, and that'll apply those settings for any masks that we create going forwards. So now that we've got our color calibration set, the first thing we're going to do is start working on the noise reduction of the image. So if we zoom or scroll in here, you can see there all of the kind of the pixelated different variations of black, and that's our noise on the image. So we're not going to remove the actual noise, we reduce the actual noise. So again, within PixInsight, there's several ways of doing this. However, I'm going to create a mask, and then using a process called Multiscale linear transform, that's what we are going to do to reduce our noise. So to create a mask, we click on this red, green, blue button, and it creates a mask based on the luminance of the image. And if I just stretch that as well, you can see it's basically a grayscale version of our image. And what I want to do here is I want to kind of make the mask more black and white, I suppose, as to grey, because when it's grey, you've still got certain areas creeping through the mask, whereas I want this to be a little bit more solid. So to make the mask solid, I'm just going to close our main image here just so you can see what we're focusing just on the mask. So we'll open the histogram transform button process and the screen transformation function, and using this we are going to adjust the shadows, or clip out the shadows, and that'll allow us to be more of a black and white style mask as opposed to this grey version that we've got at the minute. So we'll click on the bottom right hand little icons here, and that basically resets everything. We're going to then click on the nuke button, which stretches the mask for us, and we're going to drag this this stretched version into the histogram function. So by clicking and dragging the triangle across, we are taking the stretched image and saying, okay, apply this into the histogram transformation process for us. This little circle here allows us to have a preview of what we are doing. So we haven't actually applied anything to the mask. We are still just in preview mode here. But what we've got here, we've got a white preview, because we're kind of like double stretched. We're double stretched through the screen transformation function, and then we're double stretched through the histogram itself again. So we're just going to remove the auto stretch, or the double auto stretch at the top right here, and then we're back to just the single stretch. So this is our real-time preview mode, because we clicked on this circle here. So anything we do until we close the preview hasn't actually been applied to the mask yet. This is just allowing us to see what changes we're going to be doing to the mask. So I'm just going to auto clip the shadows here, and this is kind of starting to make it a bit more black as opposed to grayish. And I'm just going to move this slider along here. So if we go too much, obviously, you know, the mask isn't accurate against the galaxy, and if we go too high, the mask becomes too white. So we need this balance in the middle, where we've just got the galaxy shining through, but then I'm looking at the background here, trying to see where it's becoming more black as opposed to a grey. Okay, so happy with that. I'm going to close this window here, which is just closing the preview. And as you can see here, we're now back to the mask that we were created. However, we need to apply these adjustments that were made in the preview window to the actual mask itself. So to do that, I'll just click and drag the triangle, and this is our apply process or mechanism. And now those histogram changes that were made have been applied to the mask. So to apply the mask, so I'm just going to close these windows down so you can see the next steps. So to apply the mask, we open up our original image again, and clicking and dragging the tab here from the mask onto the sidebar, and that has applied our mask. Obviously we can see here it's red, so anything that is red is what is going to be protected. And at the minute our background is red. We don't want to protect the background because that's where we want to remove the signal, or sorry, remove the noise, or reduce the noise from. So we need to invert this mask by mask invert. And now you can see here the galaxy and the core and the stars are protected, and the background, the black areas, is where we're going to remove the noise from. The other way to tell that a mask is applied is this tab has now turned into a brown color, and that shows that the mask is applied. So we're going to I guess unshow the mask or hide the mask. So the mask is still applied, but by doing this we can see our original image, and it makes it easier for seeing what adjustments we are making. Otherwise, if show mask is on, we can't really tell any difference due to the red mask itself. So show mask, it's still being applied because this tab is brown. However, we can see the image clearly for when we make adjustments on the noise. So the process that we're going to be using is multiscale linear transform. I've got this open already. And the way this works is we split our image down into layers, and the lower the layer number, the finer the detail that any adjustments are made against. If we went up to 8 layers, we are basically splitting our image into even more defined layers. Again, number 1 is the smallest parts of the image, whereas 8 or 7 and 8 would be the larger structures within the image. So just going to click on reset to take us back to the 4 layers, which is good enough for us at the minute. And this is how we are going to apply our noise reduction. So we're going to go through 1 to 4 layers. So small fine details of the larger structures within the unmasked regions. And noise reduction, we're going to tick that because that's what we are applying within this process. So this multi-scale linear transform is used for multiple things. However, ticking it, noise reduction, tells the transform process that we specifically want to work with noise reduction here. So the 3 values we're going to fill in is the threshold, amount, and iterations. The threshold value, the higher the value, the more pixels will be treated as noise. The amount is a 0 would mean that no noise reduction at all is applied within this threshold, and a 1 means that 100% of the noise reduction is applied. And the iterations is a number of passes that this combination will go through. So for the smaller pixels, the smaller details of noise, we want to be a little bit more stronger, whereas layer 4, the larger areas, we still want to apply noise reduction, but not as strong. So I'm going to go through these settings, just fill these in, each one. So again, noise reduction, type in the threshold, type in the amount, and type in the iteration, next one down. And you can see as we go through each layer, we are reducing, I suppose, the overall strength of the noise reduction that will be made. So setting these values is a combination of trial and error, making notes for the next time you apply them and next time you work on your image again. And what we can do here, rather than just applying it, we can use a nice little feature called preview mode. So preview mode allows us to define an area, and it creates a preview. Creates a preview tab on the left-hand side here. If we click preview, we are basically looking at that preview section that we've just created. What we're going to do here is apply the noise reduction to the preview window, and this will allow us to see obviously a preview of the process itself, or the results of the process, before we apply it to our main image. Okay, so if we zoom in here, and we can do the undo or the revert undo preview. So you can see there, if we zoom right in, apply the noise reduction, nice and smooth, undo the noise reduction, we can see a lot of pixelation there, which is the noise itself. Okay, so that looks good. I'm going to remove the preview, and then with the mask still applied, because it's brown, we can double check this by saying show mask. Just remove the show mask, and then I'm going to click and drag the multiscale linear transform, or the noise reduction, into the main image itself. So when we're doing things with a preview, it is exactly that. It is a preview, and we'll have to reapply any instructions or any process to the main image itself. Okay, so that's completed. I'm going to remove the mask because we don't need it anymore. And if we look on the left-hand side here, we know the mask's not shown because the tab is not brown or reddish brown anymore. And we can now reduce or minimize the multilinear transform process. Next thing I'm going to do is do a slight stretch to the image. I'm just going to minimize these masks, we don't need them. And we do this by using the screen transfer function and the histogram transformation function again, or process again. Reset all the settings, create an automatic stretch at the bottom here. And what I'm going to do is I'm going to zoom in a little bit, just clicking with the mouse here. And this brings out our shadows and highlights, I guess, positions. And I'm just going to manually adjust these a little bit. So the reason I do this here, as opposed to kind of like a curve section, is that I'm trusting or having confidence in the auto stretch that PixInsight has applied itself. So what we're doing here, we're just stretching it out a little bit more, just to get a little bit more information, or a little bit more data from our image. Once we're happy with that, we're going to, same as before, drag it into the histogram, and then from the histogram, apply it into the image itself. Okay, we've gone white. That's because we've got a double stretch on it, and just reset it. And now the image has got our stretched histogram in there, and we're now in a kind of a non-linear state. So I mentioned before that there's several ways to do noise reduction, and one of the good noise reduction processes in a non-linear state is a process called ACDNR, which is adaptive contrast driven noise reduction. So we're going to do the same thing here to show what it does, of creating a preview. And then the settings, we're just going to use 2 in the standard deviation, an amount of 0.75. According to the manual for PixInsight, which is huge, a standard deviation between 1 and 1.5 is good for CCD images, and 2 and 3 pixels for film images. So we're just going to go in the middle here of 2, and the amount 0.75. This is the strength of the actual filter itself. So we're on the preview here, and we're just going to push this in so we can see what it actually does. And zoom in. So prior to the AC DNR filter being used and then having that filter being applied, just zoom out a little bit before and after. So again, it's just smoothing out the data, which is helping with the noise reduction. So I want to go ahead and apply that change. So I'll delete the preview and then just click and drag the process into the entire image. And then I'm just going to do a slight, just reset this. I'm going to do a slight adjustment to the black point. So what we'll do here within the histogram is we select the M31 DBE file. That's where we want to make the adjustments against. And then you might have to zoom in or zoom out just so you can see the points on the histogram. And I'm just going to push, before we do this, I'm going to click on the preview so we can see what changes have been made. And then I'm just going to drag up this point a little bit. So just to show the preview working, if we go too far, the background becomes pretty solid black, which we don't want. We're going to find a nice balance here. And the other point is interesting here is if we move it too high, we can start seeing the amount of data that's being, or pixels that are being clipped out by our change. So obviously if we go too far, we'll clip it out 98% of the pixels or the data, which is not very good. So again, it's finding that balance of maybe clipping a few pixels, but setting the background or darkening the background a little bit more. Okay, so I think we'll leave that about there. Close the real-time preview and apply the histogram change to our main image. Okay, so now that we've been working on the background, it's now time to focus on the core of the galaxy itself. So we're going to make sure we've got all our masks cleared, all our previews cleared, and we're going to make a new mask for this. But actually what we're going to do is we're going to try a different way of creating the mask called range selection. And we're going to use the preview button again so we can see what we are creating. And this time, rather than kind of more of a mask being based on the luminance, this is more of a range or an area that is being created for the mask or being used for the mask. So just to get us going, I'm going to increase the lower limit so we can see what the fuzziness and smoothness selections do. So the fuzziness, I'm just going to up this slightly. If I go too far, you can kind of see it becomes more of a transparent mask as opposed to if it's low, it's a solid mask. And for this, we're going to be working on the entire galaxy itself. So therefore, we want a solid mask. And then the smoothness, if you look at the edges, this is just how it blends in from the mask or from the galaxy into the background. So we don't want this too strong, but we want this enough that there's a bit of a blending or smoothness between the galaxy and the background itself. And then the lower limit we can now start playing with a little bit more. So what I want here is enough white area that covers the galaxy. And a little trick here is if you just click on and drag around the real-time preview, you can kind of get it to sit over the galaxy, and that allows you to say, right, well, if we do that, it's too small. Obviously, we're not covering anything of the galaxy really except for the core. So we can find that balance by a bit of eye with that. Okay, so that looks good. So we're going to close the preview and then click on the square to create the mask based on those settings. Close the process, and then just like before, we click and drag the mask image onto the main image, and that creates the mask for us. So again, it's turned brown, and if we show mask, we can see that the red is what's going to be protected. So in this case here, we do not want to touch the background. We've done our work with that, so therefore red is the background, what red has been protected, and the galaxy is the area that is going to be adjusted with the next process. Okay, so we can get rid of that mask for the minute. And, well, not the mask, but we can get rid of the image that was used to create the mask. Turn the mask off, or don't show the mask. It's still being applied because the side tab is brown. And what we're going to do here is use the local histogram equalization to bring a bit more contrast and a bit more detail out into the actual galaxy itself. Okay, so like everything else, we can use previews in this, and 1 is basically 100% is being applied, and we're going to drop this around about 3 or 4. Just move this up a little bit more. Okay, so I'm happy with that, but what I'm going to do here, just to show you before and after process a little bit easier again, is create our preview selection area, show the preview tab, and apply this into the preview. And then we can zoom into the galaxy itself, and we can do a before and an after. So what's happening here is, yes, it's changing, I suppose, the kind of contrast of the galaxy, but in doing that, we are bringing more of the dust lanes out within the image. So that's before and that's after. So we're going to close the preview and apply these settings to our main image. Remember, this has only been applied to the galaxy because the mask is masking out the background, which we don't want to change, obviously. So that change was applied to the entire galaxy, but this next step, we're going to work a little bit more in the center of the core of the galaxy itself. So again, we create a range mask, click on preview. However, this time we want to increase the lower limit so it just covers the core of the galaxy. And again, we can kind of like eye it to see whether it's a little bit too big. Let's make that a little bit smaller. Okay, and we'll go with that. So close the preview, create the mask. And what I forgot to do is remove the previous mask. So remove mask, and then with this image, we can apply it. And we've now got our new mask applied. So there you go, everything except for the kind of the core of the galaxy is being masked out. Now we're going to repeat the previous process as well. So I'm just going to pull this out of the way. Okay, let's create. I was having to think. Okay, so we'll do a live preview first. So it's just the center of the core that's been adjusted here. So obviously we don't want it too strong, but we don't want it too weak, so that there's not really much difference seen. Take this out. I'm going to apply the preview, or apply it to a preview, just so we can see what it's doing to the core. Apply it in. and then we can get a before, and there's an after. So again, we'll bring in these last dust lanes within the core, rather than having the entire core blown out too much. Okay, so let's close the preview, and we'll put that process into our live image. Now that's been applied, we can minimize the process here. So we want to remove all our masks, remove mask, we haven't got any preview windows, and now we'll move on to the next section, or the next part in the workflow, which is star reduction. So star reduction, we want to begin by creating a star mask. So this is a bit of, again, trial and error to work best for your image, depending on how many stars, or what strength you want to reduce the stars by. When I've tried this before, it didn't seem to pick many stars up. So by reducing the threshold, it will increase more structures or pick up more stars. Want to choose binarize here. So the binarize, anything below the threshold with that checked is considered noise, and it's not picked up from the mask. And basically this helps distinguish better between what an actual star is and what is just noise within the background. So we click on the square to create our mask. And then this is where we can check to see that enough stars have actually been picked up. If there's too few stars, then obviously when we come to reduce the star field in the next step, it's not going to be reducing many stars. Okay, so that's that image there. There's all the stars that's been picked up. We could improve this further by creating multiple masks and removing one mask from the other, and therefore anything that's over the actual galaxy will not be touched. But that's for another video. We're just going to do a simple star mask and use this one. Okay, so that looks good. We can minimize the star mask process itself. Like before, we just click and drag and apply the star mask to our image. So again, it's gone brown, we know it's been applied. And if we show the mask, we can see that all of the background is being protected, and it's the white areas of the stars, and it's the white areas that we want to reduce. So I'm just going to hide the mask, although it's still being applied. With the star mask, we then use the morphological transformation process. And to use this specifically against stars, the recommended settings is morphological selection. And then, like everything else, it's just a case of how strong and how many times you want to apply this process. So I'm going to go for 2 iterations. That's to apply it twice, or 2 passes. I'm going to try a selection of 0.3. So the lower the selection, the more the stars will be decreased, as opposed to anything above 0.5, the stars will be increased. So this can be used both ways for increasing and decreasing your stars. The size is the width and height of this box here, and basically you can add your own pixels or add your own shapes, and that's what the stars within the mask will be shaped to. I'm just going to choose the pre-selected one here, the circular structure. Keep our stars nice and round. And then let's do a preview just so we can see this, just so we can check that the stars are removed as much as we want. So into the preview, and then per usual, we just drop the process or apply the process. And then we get the before and we get the after. And if you wanted to make this a little bit stronger, simple way would be to reduce the selection a bit further. So we'll try that just as an example. Apply it again. So that was before and that's after. So you can see there the difference in the stars. So I'm going to stick with about 0.3 on this. Reapply it. Okay, so there's the there's the before and there's the after. Okay, so let's clear this preview and apply it to the entire image. Okay, so that's the stars now handled. So the final thing we're going to do is just some final saturation adjustments. So we're going to remove the mask, the star mask, and create a new luminance mask. I'm just going to apply this to the image as is. Again, brown means it's applied, and we can double check that by showing the mask, and the background is red, so therefore that is protected, which is good. It's the color or the saturation we want to try and bring out a little bit more in the galaxy itself. So we'll turn the mask off or hide the mask. And then for this, we'll go into curves, transformation. We'll reset everything. Click on the S, which is for saturation. We'll show a preview first. Sorry, I'm just going to make a slight regular adjustment here. Okay, so start bringing a little bit more out. So there's the before and the after. Change the contrast. I'm just going to apply that itself first, and then we will adjust the saturation. So again, we going to close that to reset this. Preview, saturation. I'm going to start pulling a bit more color into this. Okay, so I don't want to go too high and make it look oversaturated. We just want to get a nice warm balance in this. Okay, that looks good there. We can also try with the other channels. Slightly increase this. Again, too high, it looks too orange. Too low, take all the color out of it. So just a little bit without too make it too warm. And then the final one, if we want to, we can try the hue. So again, too small turns pink, turns red. Too much, it goes into the greens. So just want to balance this out just a little bit. Okay, so that's after, that was before. And I think we'll remove that preview. Apply it. And then the last thing we need to do is remove the mask.